Record. Yeah, comes on everyone. Let's start off. Great. So last thing we did was this parallel vectors. Let's see. So in different types of vectors, parallel vectors is one, and then we have equal vectors. So these are the vectors who have same magnitude and direction. So this is mostly standard stuff. Then we have zero vector. So zero vector or null vector, there are names for this. So when you subtract two vectors, you don't get zero, you get zero bar. Getting it? When you subtract two quantities, what you should get will be a zero of that quantity. So you should not say a zero scalar. So a zero vector, it has zero magnitude and undefined direction. You can take any direction you want because the magnitude is anyway zero. Others, do keep your cams on. No, these all are fine. Now the next one is important. This is something which we will encounter in circular motion and rotation. We define something called a pseudo vector. We will talk about this again in circular motion, but I'll give you a bit of an idea now. So the word pseudo meaning false. So it's a false vector, right? This is also called as an axial vector. So there are few names for this. If you remember in the beginning, I told you the whole purpose of this chapter, right, is to make your life convenient. So we define certain things because it is more convenient. So pseudo vector is one of them. I'll tell you what is this thing. Imagine you're going in a circle, right? Let's say particle is going in a circle and let's say this is X and this is Y. So when the particle is here and is going up, what is the direction of this particle?
Towards Y.
Tangential.
So J cap, right? So when the particle is here, then it is going minus I cap. When it is here, it is traveling minus J cap. Here it is traveling plus I cap. Can you see what is happening? Every instant you are getting a direction and the direction is continuously changing, isn't it? So if I ask you, what is the direction of this particle? How is this particle going? You can clearly see it is going in a circle, but the moment I try to define with I cap and J cap, it looks really confusing. Getting it? The vector is continuously changing. So people said, yeah, this is really inconvenient. So can we do something about it and define it in a more simpler form? Yeah, just give me a minute. Let me remove the people whose cams are not on, and then we can continue. Yeah. So what is a pseudo vector? So this is something we made it up. It does not give us the actual direction. That is the first thing. It does not give us the actual direction, but it gives us the sense of rotation. So this we use especially for quantities where rotation is involved. Okay. And how do we calculate this? We use, right hand rule. We find direction by using right hand thumb rule. So let me show you what is this. So consider a particle going in a circle. We observe at every instant the direction of the velocity changes. Now, this is very inconvenient. Like, if I want to define this, every time I have to define a vector which is changing with time, it becomes a little difficult. So we want something more convenient. So someone came up with an idea. Why don't we use the right hand thumb rule? So in school, I'm sure you studied this, but let me show you how we use this. So if something is going like this, so this is what we do. By using right hand rule, see, when you take a right hand, right, you have two directions. Meaning if you're looking into my screen, you have two directions. One, the fingers are curling, and the second direction is the thumb. So basically, when you say right hand, when you make a fist, there are two things you're doing. One, you're curling the fingers, and one, the thumb is pointing in some direction. So there are the two directions you have. So we take the curl of the fingers as rotation, and the thumb indicates the direction. It would look like this. There. So when you take your hand here and when you rotate it with your fingers, so here, see, the circle is going which way? Anti-clockwise. So take your hand. So think of like this. You can do it on the book which you're writing. So if this is your book, look at my screen. If this is the book, right? And if the particle is going like this in a circle. So what you do, you take your hand. So make the fingers go in the direction of the particle. So curl your finger like this. Thumb is pointing which way? Outward. Suppose if the particle is going this way, right? If it is going this way, then you have to curl your fingers in the direction and the thumb is pointing into the book. You're getting how to use the right hand rule? Now look at the fan on the top. If you have a fan there, how is the fan rotating? If your fan is rotating, try to make the fingers in the direction of the fan ka rotation. The thumb will show you the direction, isn't it? You're getting the rotation how it is? So this is how we define the direction. See, if someone comes and tells me we have a particle going in a circle, let's say this is making 3 revolutions per second. Anti-clockwise. So the mathematical way of representing this is we represent like this. So using right hand thumb rule, this is going anti-clockwise. So put your hand on the paper and rotate it. Thumb is pointing outside, right? So we will say 3 revolutions per second k cap. You guys remember the standard thing, no? This is x, this is y, z is coming out of the paper, isn't it? Z is coming out of the paper, minus z is going into the paper. Is that clear, everyone? If I give you one more example, say, suppose if I say a particle is going 2 revolutions per second I cap. What is the meaning of this? So the meaning is this. The I cap will be the direction of the thumb. So put your thumb in the direction of I cap. And then curl your fingers. That will give you the rotation. So if this is x, this is y, and this is z. So put your thumb along x-axis. So again, if you look into the screen, if this is x-axis, so put your thumb along x-axis and then make your fist. So this guy will be going in a circle like this. You're getting how it is going? It is rotating about the x-axis and the circle is going like this. So here, this particle goes in YZ plane. Maybe I'll draw it here, say. This is better. The particle is going in YZ plane. If you can visualize that. Matlab, if I rotate the diagram, it would look like this. This is Z and this is Y and X is coming out. Are you able to visualize? So here particle moves in YZ plane. The rotation is that way. So did you see what you did just now? You have eliminated infinite directions with one direction, isn't it? Now, can you tell me how is your fan rotating? Let's say your fan is rotating 10 revolutions, 2 revolutions per second. How will you tell the direction? So your fan is rotating like this. So you put your thumb like this. So it is pointing down, right? So you say my fan is rotating 2 revolutions per second downward. But tell me one thing, does it mean the fan is coming downward? So what it means is put your thumb in the downward direction and rotate your fingers. It will tell you how your fan is rotating. Is that making sense? And the best thing, you know what? This is not only here. If you see most of the things, right, that you are using are mostly made for right-handers. So did you ever get a confusion when you're opening a bottle cap or when you're opening a screw, which way to rotate? For example, look at this thing. I have a bottle here, right? And if I want to open this cap, right, this is actually a right-hand screw. So I want the cap to come out, right? You can use right-hand thumb rule, see. So I want the cap to come out. So thumb is up, means I need to rotate this way. So if I rotate this way, the cap comes out. If I want the cap to go inside, I want the thumb to be down. So if I rotate this way, the cap becomes straight. You can try with this your bottle cap, your toothpaste cap. If you see, all these things are right-hand screws. So indirectly, you know what you're saying? This cap which is there, if I rotate this way, the cap is going to come out. So the thumb will tell you which way the screw moves. Is that making sense? So if I rotate this way, the cap is going to come out. If I rotate this way, cap is going to go inside. Check with your bottle cap. So if you have to use right hand, getting it? Your bottle caps, everything work like that. Kabhi ye hua, when you're opening a screw for something, didn't you get confused? Should I rotate right or left? Generally, what we do, we start rotating it. If it becomes tight, then you rotate in the opposite direction. So you can use the same concept there. If you want the screw to come out, right? If there's a screw here and you want it to come out, so how should you put your thumb? Outside? Rotate this way. So if I rotate the screw this way, the screw is going to come out. If you want to screw go inside, then you have to rotate this way. So put the screwdriver and rotate this way. Is that making sense? Is the right hand rule making sense, everyone? So when I say this thing is going K cap, this is a false direction. The fan is not going down. But the convenience is this. With one direction, you can tell me what is the rotation of the particle. Is that making sense, everyone? Got why we call it false vector, but do you understand why we had to define it? Pretty convenient. Do you have a Camlin marker? The whiteboard ka Camlin marker? Or if you have one, or if you have seen one, try to open that. It doesn't open with right hand rule. Camlin marker is a left hand screw. Because you don't want to open the marker every time, right? Only for refilling.
Yes.
So if you use a Camlin marker, it's actually a left hand screw rule. You can try this later and check. So you have to use left hand rule for that. So most of the things, right, are made with right handers in mind, but yeah, this Camlin marker is actually a left hand screw. Are the directions clear, everyone? Let's take a few more examples. You tell me what are the directions. If I say something is rotating 3 revolutions per second j cap, how will you draw this? So this is x, let's say this is y, and this is z. So put your thumb along y-axis and then rotate your fingers. So this would be the j cap. So the rotation will be like this, isn't it? So particle rotates in xy plane. XZ plane, sorry. Particle moves in XZ plane. Can you see what is happening there? You're rotating in X and Z, but the direction is Y-axis. So let's say you're standing there. Now, if you look at your shoulder, right, your shoulder is actually a point of rotation. You can rotate your shoulder in different directions. So let's say if you have a shoulder like this, and if you rotate your hand like this, you're getting how am I rotating it? Stretch your right hand to the right side, and then you're rotating to the front like this. दिख रहा है कैसे rotate कर रहे हो? So can you tell me which way are you rotating? Remember, rotation is happening like this, right? So this way, so I need to rotate like this thing. So thumb is pointing into me, right? Is that making sense? So if you're rotating this way, the thumb is pointing inside. So the direction will be minus k cap. Are you sure, everyone? So this thing, right, we can also write it as, so we have a convention here. So let me show you that later on. So let's say, what if you rotate your hand like this? You put your hand like this. And you rotate this way. You're getting how? Put your hand like this and you're rotating front and back this way. This rotation, are you getting it? If you look at your shoulder, right, you can rotate in 3 directions. If you're looking at my screen, right, you can rotate your shoulder like this, left and right. You can rotate your shoulder like this, front and back. You can rotate your shoulder in the front of your face. There are 3 rotations you can do with your shoulder. Yes? Able to visualize that? So each rotation has a different axis of rotation. So for this guy, what is axis of rotation? This, na? You're getting it? So you got the point. So there, these are the few directions there. So that's it for now. Just have an idea about this thing. Quite a useful thing. We'll see in circular motion again. Now, one thing here, while taking directions, right, we use it like this. If something is going like this is anti-clockwise. In terms of vectors, we write this thing as minus k cap, right-hand thumb rule. It is also represented as, sorry, plus k cap. We show it with a dot. If someone shows you a dot like this, means it is out of the plane. That is the meaning of this. So sometimes people will write like this. They'll write a dot here and they'll say 2 revolutions per second. Means it is understood. Thumb is pointing out and it is rotating anti-clockwise. Suppose something is rotating this way. This is clockwise. Clock ka direction, everyone. This is minus k cap. We show with a cross, meaning this is into the plane. The terminology for this, right? It has come from this. If someone is shooting an arrow towards you, when the arrow comes towards you, what will you see? You will see a point. If the arrow is going away from you, what do you see? You will see the tail, right? The cross. So that is a concept there. If you see a cross, it is going away from you. If you see a dot, it is coming towards you. Old convention, but yeah, we stick with that. Is that clear, everyone?
Sir, what will happen for irregular orbit?
Then it will be a combination of multiple things, multiple rotations. We'll not get into that right now. Then we have to take it as, remember that thing we did polar coordinates mein? R, theta, phi, 2 rotations. So something like that, we have to make it up. It's possible to be done, but we'll see later on. Right now, I just want to give you an idea about this. All clear with this? Clear, Nadia?
Yes, sir. Sir, the person who is rotating the shoulder, it should be positive k cap, right?
You are right. I'm sorry. Plus k cap. I did a mistake, everyone. You're going anti-clockwise, na? Right hand thumb rule. It is pointing out.
Yes.
Yeah. That is plus k cap, everyone. Clear? So these are different types of vectors. Pseudo vector can be a little confusing, but don't worry. When it comes again in circular motion, I'll teach you. But quite useful. So whenever you deal with rotations, we use pseudo vectors. Next thing.
Sir?
Yeah.
In the previous page, like if we see next page, in the page that you draw the diagram, if we are looking from that person's perspective that he's rotating, then should this k cap only.
No. Let's keep it this way. See, it is always in your perspective.
Okay.
It is, remember, always you are the observer. You are looking at the person. So what you're saying is this circle. I don't care about that person, what he's seeing. If that is the case, normally that also happens. Then they will say like this: the particle is going in a circle. There's a man standing here. What will he see? They'll tell you like that. They'll ask you that way.
Okay.
Then you have to do that thing. If you don't tell me anything, I'll assume I am the observer. That's a valid one. Next thing, addition and subtraction of vectors. So how to add or subtract two vectors? Right. So thing is simple. See, what is I plus j? It is nothing. It is I plus j only. Meaning, getting it I and j are simply two different directions. Think of like this. What is 2 apples plus 3 mangoes?
Same as it is written, sir.
It is not 5 apple or mango, right? You don't create a new fruit. Suppose if I add 3 apples and 1 mango, how do you add this? You add apples to apples and mangoes to mangoes, isn't it? You don't mix up the fruits. Same way when you're saying I cap and j cap, you do the same thing. So if you have a vector a bar, which is ax I cap, ay j cap, and az k cap. And if a vector b bar, which is bx I cap, so b ka x coordinate, bx subscript, by j cap, and bz k cap. So when you add the vectors a bar plus or minus b bar, you simply add ax. So I cap components add up, y components add up, and z components add up. So that's it. There's nothing much there. So when you add, you just make sure to add i's together, k's, j's together, and k's together. Don't mix up I and j. Is this clear, everyone? Clear? Next thing. This is an important concept. In the entire chapter, if you ask me, this is the number one thing that you should learn, resolving a vector. You will keep encountering this literally in every chapter. So this is like a pretty standard thing. if you give me a vector, I want to see what is the effect of that in different directions. So we resolve the vector. So what is this thing? Consider a vector. So listen carefully, it's not tough. It is just again little geometry only. Consider a vector of magnitude A. Making an angle theta with x-axis. You can even take y-axis also. So you gave me x, you gave me y, and then you're telling me we have a vector here of length A making an angle theta. So you're asking me what is this vector? Now see, again listen, this is a verbal way of saying, right? I have a vector of A at making an angle theta. But if you want to put it mathematically, what does it mean? It means I'm traveling in this direction, x, and I'm traveling in this direction, y. This coordinate is x comma y. What is x here? X is A cos theta. Y is A sin theta. So simple way to remember is this thing, see. Whichever side is touching theta is adjacent side. Whichever is opposite theta is the opposite side. So opposite side is A sin theta, adjacent side is A cos theta. Is that clear? How did we get that? Cos theta is adjacent by hypotenuse. So shift the hypotenuse that side. So get used to that. So I can write this vector A bar as xi cap. So that is A cos theta I cap plus A sin theta j cap. So which we have done this something like this last time. So if I give you the magnitude and angle, you just give me the direction. Is that clear, everyone? So if you give me a vector A bar like this, and this is angle theta, this is what I can do. I can split this into two pieces. The vertical piece will be A sin theta. The horizontal piece will be A cos theta. Is this making sense, everyone? So if you push something like this, it is as good as pushing it forward with A sin theta and pushing to the right with A cos theta. So whenever a vector is given, you can split into two pieces like this. So this is what we call as rectangular components. Rectangular meaning both are perpendicular to each other. But is it necessary every time to divide like this? See, for example, if A is like this, and let's say someone decides this angle is some, let's say this angle is some alpha, then I can even divide this into two pieces like this. This component will be A cos alpha, and this component will be A sin alpha. Is that making sense? So basically, you can choose any line as x-axis, any line as y-axis. Is that making sense, everyone? Why should always x and y be like this? I can choose any line as x-axis and any line as y-axis. So I can even choose this as x, this is y. I can even choose this is x and this is y. Isn't it simply you're turning your head left and right? Just because you're turning your head, why will x and y change, isn't it? So that is the thing. So whenever you want to divide a vector, you can always divide in any direction you want. ऐसा नहीं हर बार x and y में divide करना है. You can even divide in any direction you want. Right, Srihari? Cos theta I cap, sin theta j cap will be unit vector. Is this idea clear, everyone? So whenever I give you one vector, you can divide into two perpendicular pieces. Advait, Aditi, Utsa, to adjust your cams a bit. I can't see you guys. What happened, Aditi? Lost your glasses?
Yeah, I kept them to the side and forgot to put them on.
Clear with this? Nah, I too don't have that problem. If I forgot my glasses, I can't see anything. So I immediately realize, oh, I'm blind.
Sir, my
Let's see
power
a
is
question.
very low, so it's 0.5
So you
and
don't realize
0.75.
that.
Yeah.
I'm so used to it, right? Sometimes I go to the washroom and take water and hit my face, and then I realize, oh shit, there are glasses. People with glasses will understand. Let's see a question. So this is x, this is y. So I'll give you some vectors. I want you to divide them into components, okay? So this is a vector. Let's say A is equal to 10. This is 53 degrees. So I want you to write in terms of I cap, j cap, like that. This is phi root 2. This is 45 degrees. Let's call this B. Let's say this is C is equal to 6. And let's say this is 30 degrees. This is 37 degrees. And let's say this is equal to 5. There. So I gave you 4 vectors, magnitudes and angles. I want you to find A bar, B bar, C bar, D bar, A bar plus D bar. Let's make it A minus D bar. Wait, I'll do even better. Let's make it 2A bar minus D bar. Okay, let's get them all. So I want you to write them in terms of I cap and J cap. Hope everyone remembers what is 37 and 53 in case you forgot. So 37 and 53 are 3, 5, 3, 4, 5 triangles. So we use that. You can get sine 37, cos 37, everything. Yeah, easy stuff. Let's get this. Finish it off. I'll give you 2 minutes.
Sir, theta will be always the angle with the x-axis, right?
It doesn't matter. It doesn't matter.
Okay.
Don't get obsessed with the x-axis. Ab simply ऐसा सोचो ना. For example, look at this guy. When I'm going from here to here, I will just go like this. I'll go like this, isn't it?
Yes.
So this is the adjacent side, na? But that is pointing y-axis, right? So adjacent side will be j cap. Opposite side will be minus I cap. So don't worry about what is x and what is y. You just simply take the directions and figure out.
Okay.
But if you want always with x-axis, you can do that also. Nothing wrong.
Okay, sir.
Get them all, everyone. Just divide them into components. Finish it off. Sit straight, everyone. Udit, sit straight. Don't lean so much. Put your hand and all. You're telling your brain, boss, it is time to sleep. Let's focus, everyone. I'll help you with the A bar C. I'll show you a few. Check it out in case you're getting confused. So this was A, which is 10, and this is 53. So indirectly, I'm asking you to find coordinates. So this and this. The bottom one is adjacent side. What is adjacent side? Cos 53. What is the opposite side? Sin 53. Just simply remember like that. Opposite is sin, adjacent is this. 10 sin 53. Sin 53 is how much? 4 by 5. 10 into 4 by 5. How much is that? 8. Cos 53, 3 by 5, 6. So basically, A bar is 6 units along positive x-axis, I cap. 8 units along positive y-axis, j cap. Is that the meaning of it? This guy is phi root 2.
Sir, at last, what did we need to subtract?
2a minus d.
Okay, sir.
Now look at the components here. Huh? This is 45. I need to go here, so I will go up. Then I'll take a left turn. Isn't this how I go? Now who is adjacent side? Whichever side touches the side is adjacent side. Keep that simple. Don't worry about x and y and all that. So this will be phi root 2 cos 45. Luckily, यहाँ पे problem नहीं आएगा. This will be phi root 2 sin 45 because sin and cos are same. So this guy is 5. This guy is also 5. So if you want to go along the B bar, you need to travel 5 units up. So 5 j cap and then travel 5 units back, which is minus 5 I cap. So I will rearrange this. So minus 5i. So we prefer to keep I in the beginning and j cap. Is that understood? So every time the angle need not be with x-axis. You can take any angle with anything. It won't matter. What about C? So C is this 6. This is 30 degrees. So I will travel down then I'll take a left turn, I will reach this point. So that is the meaning, you're traveling literally there. So this guy is the adjacent side, 6 cos 30. Cos 30 is root 3 by 2. That is 3 root 3. This is 6 sin 30. Sin 30 is half, which is 3. Therefore, C bar, you need to travel 3 units on the left-hand side, minus 3i, and 3 units downward. So minus 3 root 3. Both are negative. Right, okay, you got all of them. Right, Vanshika, he also got this. 3, nay, Vanshika. Can you see? I think you must have INJ. Don't remember this formula. Cos theta, sin theta, ye har bar valid nahi hai. This is valid only when you have theta with the horizontal. But here look at C, theta is given with vertical. Are you getting it? So don't remember the formula. Don't worry about putting in the formula. Always try to derive on your own. Just draw a picture, you will see. What about D? So this is 5 and this is 37. So how do you reach there? I'll go straight along x-axis, then I'll come down. This is 5 cos 37, which is 4 by 5. That is 4. This is 5 sin 37, which is 3. So what is D bar? 4 I cap minus 3 J cap. Yeah. Easy, everyone. And what did I ask you? 2A minus D. So I'll just put 2A minus D and finish it off. So 2A bar minus D bar will be 2 times A bar will be 6I plus 8J minus D will be 4I minus 3J. So 12 minus 4, 8I, 16 plus 3, 19J. Clear, everyone? Easy stuff. So this is not the actual stuff. So this is how we got the components. So now what you're interested is, how do we actually get this in the terms of questions? But any doubts on this page, please ask me. How did I take the component? How did I take the x-axis? How did I take y-axis? What did I do? Anything that you're not clear, please ask. Clear? No. So now we will see some physical situations and where you have to draw some vectors. For example, let's say we have a block like this, 30 degrees incline, and let's say we have a block here of 10 kg. So now if I ask you this question, do you think the entire weight is responsible for sliding down? Only a part of it, right? So now we are interested to know how much part of the weight is actually useful to slide down. So these kind of questions, what we do, we choose this as x-axis and we choose this as y-axis. Like I said, you can choose any line as x-axis and any line as y-axis. They just must be perpendicular. And we have the weight vector mg here, which is 100. I'm taking g as 10. So can you resolve the components along x and y-axis? So resolve the weight vector along x and y-axis. So x and y I gave you. X is along the incline, y is perpendicular to incline. Get this, simple one. Are you guys getting what I'm asking? So 100 newtons of force is acting down, but 100 may only a part of it is making you slide down the incline. How much is that? A part of the force is making you push the incline. How much is that? 50 I cap, 50 root 3. Like I said, it's just a geometry there. Let me help you with this, then I'll ask you something better. Look at this thing. So this weight vector, if I just drop it straight down, isn't this 90 degrees? If that is 90 and this is 30, how much is this? This is 60. This is 30. Agreed? So now look at the diagram again. So we have a weight vector. This is 100. This is your x-axis. This is your y-axis. This angle is 30. You can take any angle, doesn't matter. Now who is the adjacent side? The y-axis is the adjacent side. So 100 cos 30. This will be the opposite side, 100 sine 30. You could have taken 60 also. You will get 100 cos 60. Cos 60 sine 30, both are same. Is this clear, everyone? So what are this component? 100 cos 30 will be 50 root 3. 100 sine 30 will be 50. Means even though your weight is 100 newtons, only 50 newtons is useful to slide on the incline. Are you getting the interpretation? Is this making sense, everyone? All got this?
I didn't
Pratyusha,
understand,
Anuj?
sir.
Which part?
Sir, how did you get for if we use 60 degrees?
What is 100 cos 60?
Into, I mean, 100 into half,
How much is that?
50.
Or how much is 100 sine 30?
Okay, so that complement.
It won't matter. You take 60 or 30, meaning what he is asking, अगर ये 60 लिया होगा, you would have got 100 cos 60. That is also 50. This would have been 100 sine 60. That also is 50 root 3. It won't matter whichever angle you take. Clear with this? So let me show you the actual question. Let's say we have an incline. We have one more incline. We have the floor here. This angle is theta. This angle is theta. And between this gap here, a ball got stuck. You're getting how it is? The ball got stuck between these two things. This was an incline and this was an incline. So between two floors here, it got stuck. So this force here, so this guy is pushing with a force of N1 and this guy is pushing with a force of N2. So let's say this is x-axis and this is y-axis. So resolve the forces N1 and N2 along x and y axis. Meaning you have to give me answer like N1 cos theta, N1 sin theta. You're getting it like that. So N1 and N2 are given. I don't want the exact values. I just want the components. What is this N1 component in the horizontal direction, the vertical direction? What is this N2 component in horizontal direction, vertical direction? Is that making sense, everyone, what I'm asking? So we have a ball which is stuck between two walls like this. How will you find the angles? The answer should be like N1 sin theta I cap and N2 cos 2 theta j cap. It could be anything like that. How do we resolve? Try, think for a minute. Meaning, if you're confused, I can do this thing. Let's say example, let N1 100 de diya and N1 200 de diya. I'm asking you, find N1, N2 in terms of I cap, J cap. Understood what I'm asking? Into horizontal is into sine theta, vertical is into cos theta. You got the angle wrong. Take an angle theta theta. There are two thetas there. I'll help you with N1C.
So do we have to simplify them using 2 theta identity?
No. You can leave it like that. If you got 2 theta, leave it like that. Dekho, see, I'll show you one. Let's talk about N1 first of all. So this is the incline. This is your x-axis. This is theta. So the sphere is somewhere here. That is okay. Your N1 is like this. This is 90 degrees. So if I extend the line here, what will be this angle here? 90 minus theta. Agreed? This will be the horizontal component and this will be the vertical component. Everyone agreed with that? What is the horizontal component? N1 cos 90 minus theta. It is touching the adjacent side. What is this thing? N1 sine 90 minus theta. Everyone knows what is cos 90 minus theta? Cos 90 minus theta will be sine theta. This guy will be N1 cos theta. So if I ask you to what is N1 bar will be minus N1 sine theta I cap plus N1 cos theta j cap. This is how I want you to represent an answer. So N1 magnitude, you know, I want you to give in terms of I cap and j cap.
Sir,
Can you do the
why is
same
it
thing for N2 now? Advai?
Sir, why is it minus N1 sin theta I cap?
I cap is, देखो यार किस तरह point कर रहा है, backward ना?
Oh, yes, sir, sorry.
Got it ना? देखो ना, force is this way, so left arrow and up arrow, right? Left arrow is minus I cap.
Yes, sir. Thank you.
Yeah. What is N2? Did everyone got what did I do with N1? Now find N2. I'll give you a minute. Did anyone got for N2? Arya, signs be important karega, right? Plus and minus you have to tell. Shreyans, I wrote down the answer there, right? You can check.
Sir,
Anuj.
actually in this case, the adjacent side and the hypotenuse will be the same thing, right? Because
What do you mean by that? See, what is adjacent side? Whatever angle you take, whatever side that is touching, that is adjacent side.
that also happens to be the hypotenuse in this case, no?
This is the hypotenuse record. The main vector is always the main hypotenuse, isn't it? You're dividing N1 record. This is N1. You go left and you go up, na? That is the hypotenuse. This is the angle 90 minus theta. समझ में आ रहा है एंगल कैसा कर रहे हैं हम?
Yes.
So basically see ना this vector here ना उसको मैंने यहाँ पे लिख रहा हूँ बस. Now
Okay.
clear?
Okay, yes.
Vectors can be moved around, right? Okay, I think you got it. Aditi. Okay, both of you got two opposite. Cos and sine. Arya. Yeah. Ovia, you got opposite of these two people. So, nay, wait. You and Samyak got the same answer. So we have two people with one answer and two people with one answer. Let's see who is right. Let's look at the next one. Again, it's all about little geometry, everyone. So look at carefully here. So now you want to find N2. This is theta. Now, if from here, if you drop a perpendicular, extend the line like this is 90 degrees. This angle is 2 theta. What will be this angle, everyone? 90 minus 2
90
theta, na?
minus 2 theta.
Is that clear, everyone? If that is 90 minus 2 theta, then this angle will be 2 theta. So for now, this N2, if I drop a line like this, if that is 2 theta, isn't this also 2 theta? Can you see the parallel lines? This is N2. This is 2 theta. So this is also 2 theta. Now, what are the components? I can divide the component like this. So this side is touching 2 theta. So that is the adjacent side. N2 cos 2 theta and N2 sin 2 theta. So N2 bar is written as N2 sin 2 theta I cap minus N2 cos 2 theta j cap. Check your answers. So the question is more about getting the angles. And be careful with signs, na, Trishi? You got that, but I think minus and lena, it is going down. Rest is right, Trishi.
Sir,
Clear, na, Trishi? Ah, Aditi.
sir, I completed the triangle like upper se, so I just extended it over there, and I
Where,
think,
like this,
yeah, I just
and
extended
then
it in that. Yeah,
ye
like
90
just,
tha, ye theta. So this is
huh,
90 minus 2 theta, na?
yeah.
Then what happened? Where it went wrong?
I think I just flipped the, yeah, I flipped the two.
Think like this. Huh?
Hmm.
Suppose if I make this one more triangle, this is 90 minus 2 theta, this has to be 2 theta.
Yeah, sir, I flipped the two
Yeah.
angles. Yeah.
Check it out, everyone. Pratyasha, you also got it right. Everyone clear with this? So this is how they'll ask in the exam. They'll not ask you find components just like that. Components will be a part of the problem. Is this clear, everyone? Meaning you will see this later on. Look at this thing. So you have 3 balls here. So here you will find a lot of forces. See, N1, N3, N5, N6, N2. We will do these kind of problems later on. And look at the forces here. For each ball, we have to take components. N2 ka components, N4 ka components, N3 ka components, and then we solve them. So this is how things will be there. So you should know how to divide things into components. What is I cap and what is J cap. Let's see, we will do a few problems like that anyways. So far clear, everyone? Everyone got the idea how to take the components. This is how it is expected. Next thing, equilibrium. So what is equilibrium? If some of the force vectors acting on a body again, the components part, please have a look at this. You're confused, please ask me, get it cleared. It's very important. I know it can be little confusing, angles, what is opposite, what is adjacent and all. So please don't hesitate, at least stay back after the class, ask and get it cleared. Because this will be like your basic foundation. Literally every question you have to know how to divide components. So you might think it's a silly doubt. There's nothing silly. Please ask and get it cleared. That silly doubt only next time you don't understand, then it will lead to something else. It will keep on piling up. And getting it, I'll never think it's a silly doubt. Please ask. I used to be more dumb. I mean, just If that helps you, I'll tell you. In school, right, I still remember. Anyone knows what is this compound?
Ethine.
Yes, sir.
Right? I used to think this compound and this thing are two different things. Why? Because यहाँ पे CH था, यहाँ पे HC था, so it should be different. I used to be that dumb, so don't worry about being dumb. Get your doubts cleared. But what is there to feel bad, right? Tell me one thing. You guys become so obsessed about what others are thinking about you. Trust me, no one cares. Getting it? Frankly speaking, right? You're not that important. No one has time to think about you. For example, just imagine this situation. Tomorrow, when you're going on a road and you see someone driving a Ferrari, what do you think about it? I'll tell you, see, what the person inside the Ferrari thinks. The person inside the Ferrari thinks, oh, yeah, everyone is looking at me. People must be thinking I'm cool. Okay, now let's see what is the guy on the road thinking. The guy on the road thinks, yaar, kya acha car hai yaar. Wish I had been driving this car. Did you see? No one actually cares about the guy who's driving the car. Getting it? Let's say you scored 20 out of 100 in the exam and you're feeling bad and you're becoming like, yeah, everyone is thinking I'm stupid in the class. Getting it? But the guy who got 95, he's struggling. Arey, 95 आया, next time मुझे और मेहनत करके 100 लेके आने. He's feeling bad because he lost that one question. He doesn't have time to think about you. The guy who got 60 is thinking, यार मुझे 80 कैसा आएगा? You are the only one who's sitting there and feeling bad that everyone is thinking about me. So trust me on this. In 11th and 12th, forget about what others are thinking. No one is going to come and help you out. It is your own journey. If you're scoring 40 out of 100, fine, it is okay, right? Your job is next time target 50 out of 100. Sir, but the other guy is getting 100 out of 100. Let him go to hell. What the other person scores is none of your business. And trust me when I say this, this is a very important thing. If you keep comparing yourself with everyone and if you keep thinking what others will think, you will make your life miserable. There will be always someone better than you in something in life. Getting it? So one thing that I saw in the kids, right? They come to me and they're like, sir, I scored less. I'm feeling bad. I said, okay, I understand. Sir, but my friend scored more than me. That is what hurts them more than that you have scored less. So unfortunately, this is something which you learned in school. School mein, that is a kind of, it is not a healthy competition. It's a very important trait. You don't care about what others are doing. You focus on yourself, your subject. If you're scoring 40, aim for 50. If you're aiming 50, aim for 60. Let the other guy get 100 out of 100. Let him go to hell. It is none of your business. I'm telling you seriously this thing. I have seen brilliant kids messing up their whole, exams and careers just because they got obsessed about, thinking what others are thinking about them. Right? If this helps you, I'm telling you again, you are not that important. It's a very liberating statement, means you need not care about what others are thinking about you. You can just focus on yourself. You can just focus on your own learning and your own happiness. Clear? So if you have a doubt, you have a query, you ask. Let others think you're stupid or something. Trust me one thing, no one actually thinks that way. And this I have seen in life. The person who is successful will never try to demean you or demotivate you. They will never think like, yaar, what is this? And I have seen this personally in the gym. When a fat person comes into the gym for the workout on the first day, I have seen this personally. The fat person, right, will think, yaar, sab log mujhe dekh rahe and everyone is laughing at me. But the guy who's actually the best guy in the gym, who is working out with good muscles, what he's thinking, I used to be like this once. Good thing this person has come to the gym and is working hard, right, and trying to prove something. Trust me, the people are very encouraging. Only the person who is little fat is getting worried, like, yeah, everyone is looking at me thinking I'm fat. But everyone in the gym is actually very encouraging and they actually are happy that someone is trying. I have seen this everywhere. Suppose tomorrow, if you're doing a startup and you go with a business idea, a lot of people will help you with the startup. You know why? This happened with me only. 2 years back, someone called me and said, sir, I'm trying to start up a coaching class. I don't have material. I'm doing like this. What do you think I should do? Right? I asked him like, how did you get my reference? He said, sir, aapka friend jo hai na, so and so friend, he gave me reference. I said, okay, what are you doing exactly? He told me, sir, I'm starting the classes. I'm doing it from 3 months. My students are struggling. We don't have enough material and everything. I gave him 120 GB of content for free. And I told him which material to use, which material to print, how to teach, what to do, right? I gave him recordings. I gave him everything just for free. You know why I did that? When I started my classes, I didn't have content. I was literally struggling to make questions. I had to type the questions by myself. I had to struggle a lot. When he said that, I only remembered one thing. I struggled a lot. At least this guy will get an advantage, right? What took me 3 years, this guy might do it in 1 year. Good for him. So trust me on this. People who are actually serious about studies and who are actually, whatever the good students you call, they are actually helpful. They really don't care. They don't, think about demeaning everyone or judging you. So don't worry about that. Focus on yourself. Work on that. This is there. So ever happened to you? You're going on a road and your shirt, there is a, let's say your hair is very bad. The barber did a very bad haircut. And when you're walking on the road, you're thinking everyone is looking at me and thinking my haircut is bad. You know what? 90% of the people don't even notice that you exist. Only you're conscious about it. So take it from me, not as a teacher, but someone who lived more than you. I lived at least 18 years more than you, right? Double your age. So I know it really doesn't matter. No one thinks about you anything. Everyone is busy, obsessed with their own lives. So you focus on yourself. Because there is one kid who did this thing, 2022 batch mein. That guy, I thought he will get in top 100. But down the line, somewhere he got so obsessed about what others are thinking, he went into a negative trap and he couldn't get out of it. He got disqualified in advance. It was a very bad thing. He always used to get obsessed, like, yeah, what others are thinking. He used to score very good. He used to score 90s and 9 out of 100. In one exam, he scored 60 and he started feeling everyone is judging him. I don't know why, what happened to him. And we couldn't get him out of that feeling. So this is important. So I told him, yeah, it doesn't matter. One exam, no one cares about you. No, sir, but people think, previously I got all the marks by fluke. Yeah, why are you making up stories on your own? So people do that. And unfortunately, your schools are one responsible. I hate schools. But the only good thing about schools is friends. Don't you agree? At least if you ask me, the only good thing about schools, you go to school and you can play with your friends. Who the hell is interested in learning all those languages and social studies? Right? I though never liked it. Don't you ask yourself, why should we study English, Hindi, 3 languages, social studies, economics, civics, geography? I hated it, yeah. So yeah, the only good thing about it is friends. Anyways, let's get back to this. So F1 plus F2 plus F3 plus F4 is 0 bar. So keep this in mind. If there is a body, and if you say it is in equilibrium, then if you add all the forces, they should cancel out. So what do you mean by equilibrium? It is not moving. At least that's what we can think. So remember here, if the body is in equilibrium, then the component of forces in any line cancel out. We'll talk about this. Take a break. Come back by 9:41. Let's have a small break.
Sir,
Yeah. Any doubts so far you can ask. हाँ Advay.
that isn't 0 but essentially means 0 only.
See, problem kya hai na? If you just write 0, it becomes a scalar. So if you subtract 2 quantities, you can't get a scalar. Vector minus vector must still be a vector.
Okay.
So 0 bar is technically, yeah, it is 0. It doesn't make much, but we will just stick to the convention.
Okay, sir.
That way. It's like, see, if I say there are 3 apples minus 3 apples, how many apples you have? You'll say 0 apples, right?
Yes, sir. That's true.
If you simply come and tell me 0, then I'm confused. What are you talking about?
Yeah, that's also.
So it's like 3 apples minus 3 apples is 0 apples. 2 oranges minus 2 oranges is 0 oranges.
Yes, sir.
If you simply say 0, we are confused. So that way.
So their components cancel each other.
Right. You can say something like that sort. Vanshika, you're saying something? Arrows should point towards the object. No, ऐसा नहीं है. Think ना. If you're standing here, 2 friends are pulling you this way and 2 friends are pulling this way. Na? So the arrows will cancel out, right? So if they're also pushing you this way, then what will happen? Won't you keep moving forward? Got it? If 4 friends are pulling you and you want to be at rest, they should pull in opposite directions, right? Is that what you're asking? Sure, no? Or confused? You can just unmute and ask me if there is something more. Clear? Go, take a break. Go outside and yeah, null vector written as 5. Nee, we just write it as 0 bar. Okay? Yeah. Chalo, come back in 3-4 minutes. Chalo, let's start off. Great. So let's see a question. Let's say we have a block here of 10 kg. You tied it like this with 2 strings. So this string is pulling with tension T2. This string is pulling with tension T1, and let this angle be 30 degrees. Let's take gravity is 10, so the weight will be 100. You getting how is this? So this block is being pulled by 2 strings and the weight is pulling down. So block is attached to 2 strings at rest. Find T1 and T2. Let's try this thing. Think for a minute. I'll show you one model, then I'll ask you more. But did you get the diagram what it is? We got a block of 10 kg, 100 Newton. The weight is pulling down. This string is pulling horizontally and this string is pulling in, the string is pulling up. Sorry. And T1, T2.
But for the two vectors, we can take different x and y axis, right?
You can do, but preferably you choose one. Okay, we have an answer. 200 and 100 root 3. Let's see. Others try. I'll give another 30-40 seconds. Let me show you one model. T1 is 200. Right over here. You got it. Right, Samyak. Let's see. So this is T2. This is T1. This is your mg. So look at this thing. So it is given this angle is 30 degrees. And this angle is also 30 degrees. Agreed, everyone? Now I can resolve this T1 into components. So this will be T1 cos 30 and this will be T1 sin 30. Any doubts on this? So T1 can be divided into vertical and horizontal. Now in the vertical direction, now you tell me in the vertical direction, what is this T1 sin 30 doing? Isn't it balancing this 100? So in the vertical direction, the T1 sin 30, the vertical component of tension, is balancing the weight 100. In the horizontal direction, this T1 cos 30 is pulling it left and T2 is pulling to the right. Since the block is not moving, both of them must be equal. If they're not equal, the block will move. Are these two equations making sense, everyone? The string T1 has two forces, vertical and horizontal. So the weight 100 is balanced by T1 sin 30 and T2 is balanced by T1 cos 30. That's why the block is not moving. If they're not balanced, the thing would have moved. So you're done here. What is sin 30? Half 100. So T1 is 200. Then take T1 from here. and substitute here. This will be 200 cos 30 is root 3 by 2 is equal to T2. T2 is 100 root 3. Easy, everyone. Did everyone get what we did? We resolved the tension into components, horizontal and vertical. All vertical forces will cancel, all horizontal forces will cancel. You just balance them. Easy? Devanshi, clear this? Anuj? Clear, na Devanshi? Sure, right? Sudhit? Utsa? Utsa, clear? Sudiksha? Next one. Same one, but I'm just changing it a bit. We have two strings like this. Let's say this is 5 kg, 15 newtons, and let's say this is 53 degrees and this is 37 degrees. Let this be T2 and let this be T1. Find T1, T2. Same thing, but this time you have to divide both T1 and T2. See, someone needs to use washroom, need to get water or something, you can just message me and you can go and come back. Let's do this. This thing involves a little more working, but the idea is still the same.
So also we will require both the T1 and T2's vertical component, right?
Two people are balancing the weight. No?
So
Think of
both,
like this. We are hanging like this with both the hands, right? Both the hands are supporting the weight, isn't it?
so both of their sums will be 50, like that, no?
Yeah, yeah. Okay. Oh, yeah, I think that is wrong. Aditi, that is wrong. Arya, can you tell me which one is T1 and which one is T2?
So T1 is the greater one and T2 is the smaller one.
Okay, let's see. Okay, let's see, everyone, did you get the forces right? If that is 37, this is 37. That is 53, this is 53. So let's resolve the forces. This guy is 100. This thing will be T2 cos 37. This will be T2 sin 37. This will be T1 cos 53. And this will be T1 sin 53. Did everyone get this component? This everyone should be comfortable. This is what I was teaching you today, right? Full components. Oh, yeah. Now, in the vertical direction, two people are balancing the weight. Who are the two people? T1 sin 53 and T2 sin 37. So this is 100. In the horizontal direction, this guy and this guy are fighting with each other. So both are opposite. So T2 costs 37. We must cancel. T1 costs 53. Are these two equations clear, everyone? That if you got these two equations, physics is over. Now it is just a math. Cos 37 is how much? 4 by 5. Cos 53, 3 by 5. So we get T2 will be 3T1 by 4. Take this thing, substitute here. So this is T1, sine 53 is 4 by 5. T2 is 3T1 by 4. Sine 37 is also 3 by 4, is 100. Yeah, wait, yeah. 3 by 5. How much is this? So take out T1 common. You will end up with T1 by 5 common. You will get 4, 4, 16 plus 9, 25 by 4. So 5s are 20s are 40. Sure. Once you got T1, take it and put it back again in this. So we will get T2 is 30. Please check your steps. If you got the equations, then if you didn't get the answer, you must have messed up the calculations. Right. Everyone got the steps.
Sir,
Advay.
can you explain the whole problem again? I was having a little trouble in the network.
There's nothing there. See, this is 37, this is 53. That angles you got.
Yes, sir, that I got.
So ये component cost 37, T2 का, this is vertical is T2 sin 37. T1 का cost 53, T1 sin 53 vertical.
Yes.
So then हो गया ना, these two people are balancing weight. This guy and this guy are cancelling out. So this is one equation and this is one equation.
Oh, okay, sir.
Then हो गया ना, then it's just a matter of solving. All clear with this? Everyone got the steps. What did you do, Srihari?
Sir, first I took the resultant in vertical direction, sir, as you told. And then, sir, in the larger triangle, where 53 and 37 are angles, that's a right angle triangle, sir.
And now every
And
time you won't be so lucky, na? This time I got 90. What if it is something else?
yes,
No,
sir.
that is fine. That I agree. Every time you won't be lucky, na? So we have to assume it is not that way. You're not wrong. You're not wrong. Next one. Let's say we have a sphere here. Like this. So we have two tables, right? And this sphere is stuck between the two tables like this. So this sphere, so this table is pushing with N1. This is the center. This table is pushing this way with N2. This angle is 30 degrees and this angle is 60 degrees. And the weight of this thing, mg, let's say is 100 newtons. You're getting this? So a ball is stuck between two tables. A sphere of 10 kgs. Stuck between two tables. Find N1 and N2. There. So no one will ask you find a component of A bar, B bar, I cap, J cap. No one actually wants that. What people want is finding components like this. If I give you a physical situation, how will you resolve the components? But is everyone comfortable with components now? You're getting right how to take vertical, how to take horizontal. Let's get this. 50 and 50 root 3. Okay, we have one answer. Let's see anyone else got it. You're right, Arya. Right, Pratyasha. Oh, we are integrate two big values, right? Pura weight ही 100 है. Okay, you changed it. Nah, I think something went wrong with your answers. Check again.
Sir,
Show you everyone how to take the components.
do we have
Anuj.
do we have to use the concept of common side?
There's nothing there. I gave you angles. कुछ नहीं था उसमें. देखो ना. Instead of strings, I just gave you a table now. Look at this, everyone. So if I take the sphere, so this is n1, na? This angle is 60. What are the components? So if that is 60, this is also 60. Everyone agrees? So what is this component here? N1 cos 60. This is N1 sin 60. Yes? So this is N2. This is 30. This angle is also 30. So this will be the adjacent side. N2 cos 30. And this is N2 sin 30. And your weight is 100. Can you tell me who is balancing the weight? This guy and this guy, isn't it? The two vertical components are balancing the weight. So N1 cos 60 plus N2 cos 30 is 100. And horizontally, this guy and this guy are cancelling out. Are you getting the theme by now? Every question, the story is still the same. You divide them into components. Horizontals will cancel, verticals will balance the weight. N1 sin 60 is N2 sin 30. So you're done here. So this will be N1 root 3. That will be N2. So take this N2 and substitute here. N1 cos 60 is N1 by 2. N2 is N1 root 3. Cos 30 is root 3 by 2. This is 100. Root 3 is 3. So 3 by 2 plus this is 2 N1 is 100. N1 is 50. Take this and put it back there. You get N2 is 50 root 3. Yep. Right, okay. Right, Vanshika. Most of you got it. Good. Trishi got it. Aditi got it. Samyak. Arya. Yeah.
Sir,
Other steps clear, everyone. Anuj.
I did it in a slightly different way.
You should still get the same answer.
Yeah, I mean, what I tried to do was this line of the 100 Newton wala force, I took it as the x-axis for both of them.
Okay.
And with that, when I calculated, I got similarly.
Let's see. But that won't work. I don't know what you did exactly. You can send me a photograph in WhatsApp. We'll see after the class. We can discuss.
I don't have a number actually.
I'll send you. Don't worry. We can send it in Zoom also.
Okay.
I'll send you a number. Don't worry. Is this clear, everyone? But got the steps of this one? Now, if you got an alternate method, no props. You can always send. We can discuss that. But if you got a wrong answer, means your method is wrong, right?
No,
So there is something wrong.
got
We'll
the
see what
same
went
thing.
wrong. You got the same thing. Then fine. Now you did the same thing. Then nothing wrong. I took this as X. You took this as X.
Yeah.
Then I told you, it doesn't matter whom you take as X and Y.
Okay. Okay.
Then you did
fine.
nothing else. You're looking straight. I'm looking like 90 degrees. बस इतना ही difference था.
Acha, okay, I got it.
Next one, everyone. So we got a sphere like this. You're getting it? So this spear got stuck between the wall and an incline. There. So this ball here got stuck between these two things. So this wall is pushing with, let's say, N1. And this incline is pushing with N2. This is 90 degrees. And let's say this angle is some 60 degrees. And the weight of this thing is, let's say, 100 newtons. Right? So a spear is stuck between a wall and a wedge. Find N1, N2. We'll do one thing, right? I'll just change variables here. Let's call it mg from now onwards. And let's call this thing theta from now onwards. So instead of numbers, we will get answers in terms of mg sine theta, mg cos theta, like that. This is better. Let's stick with variables from now onwards. Because exam actually will need to get used to variables. The spear is stuck between wall and the wedge. Get this? Idea is still the same. The horizontal forces will cancel, vertical components will balance weight. How do we do this? Okay. N2. Samyak, that is okay. Did you get the angles wrong here? Just check again, Ovia, once more. The theta thing is not looking right. Arya, okay, you took mg 100 ले लिया क्या?
Yes, sir.
Okay. Yeah, that looks right, Arya. Any other answers? If you got an answer, you can type in the chat box to the co-host. Don't worry about getting a wrong answer. Getting a wrong answer is much better than not getting anything. So get a wrong answer. This always helps. And Vanchika, I think you also took the theta something. Theta you took wrong, I guess. Shreyans, you are right. Yeah, Pratyasha, that looks. Let's see. See, I think most of you got the component. Somewhere during calculations, you must have done some mistake. I think you guys got confused with the angles here. See, if this is theta, this is 90 minus theta. So components क्या होगा? This will be the horizontal component N2 cos 90 minus theta, which is N2 sin theta. This will be the vertical component. That will be N2 sin 90 minus theta, which is N2 cos theta. If that's confusing, you can also say this is theta, isn't it? So vertical is cos theta, horizontal is sin theta. Please check. I think that is where some of you goofed up the angle part. So on the sphere, these are the forces we have. So this guy is N2, this guy is mg. So this guy is N2 cos theta. This guy is N2 sin theta. This angle was theta, which I showed you there. Then now you're done. So in the vertical direction, N2 cos theta is mg. Yeah, this is fine. You'll get used to it, angles and all. The more mistakes you do, the faster you learn. My chemistry sir always used to say something. I don't do so many mistakes in the class. There are no mistakes left to do in the final exam. He was a deadly teacher though. This is mg tan theta.
Sir,
Clear, everyone? Got this?
N1 will become 0, right?
Why?
Because it is perpendicular and cos 90 will be perpendicular. 0.
God, these two are balancing, right?
I didn't understand. Sorry.
These
I
two are
mean,
balancing. What are you talking? N2 sine theta here is balancing N1. What 0? Think about it. Let's see after the class if you're still confused. You need to balance horizontal forces. This guy is equal to this guy. Didn't you
okay.
get this? We are doing till now the same thing now. What happened suddenly? You're sleepy.
No, okay.
No, that
I
happens.
was only thinking about the vertical ones. Okay,
Then
sorry.
horizontal we balance karo na.
Sorry, sir.
This is horizontal. No, don't be sorry. I'm just saying. I understood you're sleepy. Happens after 1.5 hour class. Students feel sleepy, teachers feel sleepy, but teacher can't show it. Students have to show it. Next one. Let's see something little different. Let's say I have a box. And here we have a wall here. So we are going to tie this with 4 strings like this. So this is point O. This is a cube of side L. The mass is M. So basically this side is L. This is also L and everything is L. The strings are also length L. So you connected them in these corners, A, B, C, and D. So this will have some tension T1. This will have some tension T1. So all are identical, so they'll have same tensions. Then you said, okay, why don't you do something else? So you had another idea. Instead of connecting like this, you said, okay, what if I connect in the centers? So E, F, G, and H. Basically, these are the midpoints. Same question. It's the same cube, same length, everything is same. So these strings are also length L, L, and L and L. But in this scenario, you found out the tension is different. This is T2, this is T2, this is T2, and this is T2. So if you connect at different points, the tension changes. Same mass. Find T1 and T2.
In respect to variables, sir?
In terms of M, M is given. Na? Is the diagram clear? Meaning, you know, how will the picture look like? There. I'm pretty sure you must have seen this in some movies or somewhere or something. Can you see that box, how it is tied? The 4 strings are connected to the 4 corners and the box is connected to this joint. Now you're able to visualize the diagram? Normally this is the most stable way. This thing, right? This thing will actually start rotating. So people don't tie like this normally. But let's see what will be the tension if you have done this way. Let's get this. All strings are length L. The cube is also length L. So Try. I'll give 3 minutes for the first one. I'm still teaching the same thing, how to divide components and balancing the forces. That I don't know, Vanshika. You need to figure it out. Why will that be 60? That will be 60, but I think you don't need that angle. That is, I know, OAD will be equilateral triangle, right? So that will be 60, agreed. But I don't think that is useful to you. Think. Take your time. It's okay if you don't get an answer. It is completely fine if you don't get the question. But if there are 10 steps, figure out at least 1 or 2 steps. That's your job. Think about it. I'll show you how to find T1, then I'll give you 2 more minutes for B part. But first you would spend 2-3 minutes on the first one. T1, what did you get? Oh yeah, but there's no H here.
Well, like if we drop that perpendicular, like
You have to find, no, I didn't give you that. How can you give me something in your assumption? Utsak, there are 2 different questions, right? This is T1, this is T2. So yeah, you have to drop T1, T2 ka components and solve. Components se solve karna hai. The whole point is that only. How will you take the components? That is a catch. Sri Hari. Yeah, we have one answer, Sri Hari. Samyak, I didn't understand exactly what did you type. I think you're also right, Samyak. Yeah, we have 2 answers. Think. I'll give 1 more minute. Should I give you a small hint? Think, take a minute, then I'll show you. Arya, you got both equal. They're not equal, right? God. Both the tensions are not equal. T1, T2 definitely are different. You goofed up somewhere. You got T2 right, but T1 is wrong, Arya. Check it out. Shlok, that is right. We have 3 answers for T1 so far. Satyasha, you're right. We have 4 answers. There, let me help you with the angles. So in the first part, what you're calculating is actually this one, see. So when you drop it from the center, I agree. You don't know H Ryovia, but you know the base, na? This is half diagonal, isn't it? Isn't this? This is an half diagonal, na? Now you can find H what you want. And this is length L. Is this clear, everyone? So if you drop a point O say perpendicular, so what is this angle? Isn't this angle 45 degrees? Cos theta is L by root 2 by hypotenuse. Are you guys getting the angles, everyone here? So these strings are actually making 45 degrees with the plane of the cube. Right, Tanishka? So Diksha, are you clear? How did you get the angle?
could you
Yes.
So
explain
Diksha,
it again? I didn't get it.
देखो ना, length of the string is L. This is understood.
Yes.
Let's call this O A and let's call this thing O dash. So if I take this triangle here, O, this is A, and this is O. This is length L. What is AO dash? Isn't this the half diagonal? ये पूरा diagonal है ना? What is the full diagonal? L root 2. What is L root 2 का half? L by root 2. So what is cos theta? L by root 2 by L, 1 by root 2. Theta is 45.
So how did you get L by root 2? I didn't understand.
God, diagonal रे square का. You really have a problem with your little fundamentals, I guess. So you don't know the length of a diagonal? Pythagoras theorem, L and L root 2. What are you talking?
Okay, fine.
And then half of it is how much? L root 2 by 2. Clear? You need to definitely revise a bit of a geometry, Anuj. You're getting confused with small stuff.
Yes,
Right?
sir.
So I can teach you concepts, but if you ask me length of a diagonal, it will be a little difficult. Then what to do? So we got 4 components here. Did everyone clear with the angles now? So that means when you have this tension T1 here, this guy is making 45 degrees. So what are the components? So this component will be T1 cos 45. This will be T1 sin 45. You're getting how did you divide the components? One in the plane and one vertical. Similarly, this will be also vertically T1 sin 45. It will be inside T1 cos 45. This will be T1 sin 45. Inside will be T1 cos 45. Inside will be T1 cos 45. And the vertical will be T1 sin 45. And you have weight mg done. So now you tell me who is balancing the weight. Who is balancing the weight? The 4 vertical components, isn't it? So this person, this person, this person, this person, these 4 are balancing the weight. Any doubts on that? So 4 times T1 sin 45 is balancing the weight. Sin 45 is 1 by root 2. So we get T1 is mg by 2 root 2. Right, Utsav. Is this clear, everyone? So the main thing in the question is to figure out that angle will be 45. Anyone still confused why it's 45? Anuj, are you sure about this?
So I have to see that square ka diagonal wala theorem
There is
again.
nothing there, regard. See na, this is L, right angle triangle, L root 2, Pythagoras theorem. Okay, think about this. You check it out once.
Yes, sir.
Is everyone clear with this? Now can you do the second one? I'll give you a minute. Now, yeah, I think second part, you got it. Ishman, you got it. Srihari, you got it. Arya, did you get it? You got it, Arya. Yeah, I think most of you got it. So what is the angle for this? So just draw the geometry again. So from here, you are going to the top, and if you drop a perpendicular, now this is a midpoint, right? So this is length L. Won't this be half of the side, everyone? This will be full side, right? That will be half of the side. So what is this angle? 60 degrees. Cos theta is half. Is that sure, everyone? And then you're done. So if you take components here, so if this is tension T2, the vertical component will be T2 sine 60. The horizontal component will be T1 cos 60. T1 cos 60, T2 sin 60. So there'll be, this is how you divide the components in 3D. So there'll be 4 sin 60 components which will balance the weight. So 4 times T2 sin 60 is mg. Sin 60 is root 3 by 2. So T2 will be mg by 2 root 3. Which one is bigger, T1 or T2?
T1.
T1 was bigger, right? It was 2 root 2. This is 2 root 3. There's a denominator is bigger here. So that means if you connect in these two ways, can you tell me in which case the string is more easy to break?
T2 1 like
T1 1.
T1, na, there's more tension here. The strings are under more stress.
okay.
See, for the same weight, these strings have to put more load compared to these strings. Is that making sense, everyone?
So then you said usually we see the T1.
Yeah. So the thing is, if you connect like this way, right? If this thing tries to rotate, na, there is a chance these strings will start, what do you call, will start getting twisted. Right? These things, right? There's something called a stable and unstable thing. This is actually unstable. Even though you get less force, there is a risk of, the strings getting, what do you call, whirled up. They'll get twisted. So that is the thing. That is the reason if you see normally, right, we always keep it on the edges. If this box tries to twist, it will come back to the normal position again. The box will be like this. But in the second case, the box will completely get twisted. So even though it takes more stress, it's more stable. Clear with this? Now I'll give you one homework question. I want you to try this as a homework. So next class when we meet, we will discuss this. It's a good one. So listen to the question carefully. So we got a cube here. It's a cube of side A. Imagine the room you're sitting. Okay. At the center of the cube, you kept a mass m. And then what you did, you tied this mass m to here, and you tied this one more string here, and you tied this with one more string here. This is point A, this is point B, and this is point C. C is the face ka center. Again, listen to the picture how it is. See this thing. You're sitting, right? Imagine this thing. You're sitting in a room that's a cube. The wall in front of you, are you imagining? The wall in front of you, look up. You can see the two corners. The wall in front of you, upar na, look up, and you can see two corners. Those are A and B. Right? The wall behind you, uska midpoint is C. And the mass M is in the middle. Are you able to visualize how it is hanging? So you kept a block M in the middle. Two strings are going like this in the front direction to the two corners of the wall. And one string is going straight back behind. Everyone is able to visualize the picture, right? So now in these strings, this string ka tension will be T2. This string ka tension will be T1. This string also will be T1 by symmetry. You need to find T1, T2 in terms of M. Getting it? So A and B are corners. So this is what I was telling you, right? You need to be able to visualize things in 3D. C is the face center. A cube has 6 faces, uska center. So mass M is at the center. Right? Which is tied with the strings. Mass M is at the center of the cube. Tied with strings connected to ABC. Find T1, T2. Again, I'm still teaching the same thing, components. So try to figure out this. It's a pretty good one. So next class when we meet, first thing in the class, we will discuss this. So spend some time on it, right? It is fine even if you spend 15, 20 minutes or more, it is worth it. Take your time, you still have time. So we'll wrap up with this. So that's the last one for the day. So next class when we catch up on Tuesday, we'll continue with here. So today we saw what we did. This is what I was saying, how to take components. So today's class is quite important. So please make sure to go through this. Anyone is still confused with how did I take components? What is sine? What is cos? What is adjacent? What is that stuff? Anything you didn't get, please ask and get it cleared. But you saw some problems. This is how they're going to ask in the exam. No one will ask you what is I cap, what is J cap. No one cares. This is the actual stuff that we need. So try this. It's a good one. Right? Okay. With that, we'll wrap up for the day. So next class when we catch up, we will do with something more. Like, you know, we have parallelogram law vectors, triangle law vectors, and all that stuff. We will do that stuff. So if you have any doubts, anything, you can stay back and ask, or else you're free to leave. So take care, stay safe. I'll see you on Tuesday again at same time, 8:30.